This is the first page of trigonometry bookwork. Um, the first thing that we need to learn how to do is whenever you get a fresh calculator, a calculator that has just been reset, the mode on the calculator has been set to radians, which is a system of angle measure that we do not use in this class. So always switch to degrees first by going to degree and hitting enter, and then you can quit by doing second quit. So you should always do that at the beginning of an exam session or something. If you borrow somebody's calculator, but you should always check that before you do any kind of trigonometry assignment. Okay? All right. Now, just a review about SOHCAHTOA. Um, you might have remembered during the investigation, but sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, which makes the mnemonic SOHCAHTOA. Okay. Remember that the way you identify the adjacent and the opposite angles is they are the sides that are the right angle sides. So like there's the right angle. The opposite and the adjacent are going to be next to the right angle. The hypotenuse is the diagonal line that is not next to the right angle. It's opposite to the right angle, right? It's opposite to the right angle. And then how do you identify the opposite and the adjacent? Well, the opposite angle is the opposite to the special angle you're looking at, which it's going to be this angle or it's going to be this angle. Okay, this one's marked alpha, so I guess this is going to be the special angle here, alpha. And the opposite would be the side that is opposite of the angle alpha. Okay, we've defined sine, cosine, tangent. Now they're going to ask us to start identifying which sides are opposite or adjacent to certain angles. So they've labeled the triangle with vertexes. So there's X, Y, and Z. And you notice they did it counterclockwise, or I mean clockwise, in the direction of the clock. And that kind of is a system that they use in this book. Okay? And so if we're going to identify the hypotenuse is the diagonal side. Let's mark it pink like we did above. The diagonal side is X, Y. So that one's done for you, right? Okay, now the legs. There's this leg and there's this leg. The opposite leg would be this one here, and let's mark it red. Okay, so the opposite leg is this one here. So it's Y, Z, right? And the adjacent leg, let's mark it yellow, is XZ. Okay? All right. Now let's look at this next triangle. So we have the hypotenuse, we're going to mark it pink, and it's the diagonal one, right? So that's BC. And then let's see, the angle we're looking at here is this angle alpha here. And the adjacent leg would be the leg that's next to it, so that would be AC. Oh, adjacent would be AC. And then the remaining side, which is opposite to the angle, is AB. Okay. It's important to be able to identify these legs. And legs are the two sides of the triangle that are next to the right angle as opposed to the hypotenuse. It's important to understand which of the legs is adjacent and opposite because that will help you figure out which trigonometric function you're going to use. Okay? So let's identify the hypotenuse again because that's kind of the easiest one to identify. That one hopefully you'll never get confused about. And if we want to identify it in alphabetical order, we would say QR, right? And the adjacent would be here, PR. And then the opposite angle would be PQ, right? And there's error in my printing, so I've written them by hand, but in yours it should be fine. Okay, So basically we have here triangles that we only know the names of the vertexes or the points. They're like A, B, C. And we know which angle we're using as a reference angle, which is the Greek letter delta, um, lowercase delta. And we are going to write the sine, the cosine, the tangent of this Greek letter delta angle using the names given by the vertexes. So you know how you call, as we did above, this line would be AB, this line would be BC, and this line would be AC. So the sine is going to be the opposite side divided by the hypotenuse. So it would be BC divided by AB, right? And the cosine would be AC divided by AB. And the tangent would be the opposite, BC, divided by AC, right? And I've color-coded these just like I did above. Hypotenuse is pink, the opposite is red, and the adjacent is yellow, okay? We usually put the letters in alphabetical order when we name the line segment, so like AC instead of CA. All right, now part C. Now we have triangle DEF, and we have the angle delta here in the vertex named F. We're going to do the same thing. We color code the sides. The opposite is red, the adjacent is yellow, the hypotenuse is pink. And then we're going to figure out that the opposite over the hypotenuse is red over pink, so that's DE over DF. The cosine is adjacent over hypotenuse, so that would be yellow EF divided by the pink, DF. And finally, the tangent is the opposite over the adjacent, so that would be red divided by yellow, or DE divided by EF. Okay? Now let's move on to page 2. The first thing we're going to do is we're going to verify that our calculator is set to degrees like we did before. Okay, we're going to go mode, and then we say, oh good, it's on degrees, and then we quit. Okay, and now it says find the exact value of sine, cosine, and tangent. And like for example, in this first one, they gave us that this side is 4 and this side is 5. Notice that this side is the opposite and this one is the adjacent. So the hypotenuse, for example, they didn't tell us how long it was. But we could still figure out the tangent, right? The tangent of alpha would be equal to the opposite over the adjacent. And the opposite, remember, is the red. So that would be 4, length 4. It would be divided by length 5 as the adjacent. So, you know, that would be 0.8, for example. Now, how are we going to figure out sine and cosine since they both require the hypotenuse, and we don't know the hypotenuse? Well, remember, we know another way to figure out the length of sides of a triangle if it's a right triangle. And, you know, this is a right triangle, which is symbolized by this square mark. How do we figure out the length of the hypotenuse? Well, there's something called Pythagorean Theorem, where we could take the red side, square it, we could take the yellow side, square it, we could add them together, and that should give us the pink side squared. Okay, so let's say that the pink side is called h. So we can make an equation, a Pythagorean Theorem equation, and we could say 4 squared plus 5 squared equals h squared. Okay, so h squared is 4 squared plus 5 squared, that's 16 plus 25. 16 plus 25 is 41. So h is equal to the square root of 41, and the square root of 41 is about 6.4. Okay, so now we can use the length 6.4 for our hypotenuse. So the opposite is 4, the hypotenuse would be 6.4, the adjacent would be 5, the hypotenuse would be 6.4. And so we have 4 divided by 6.4 is 0.625. And 5 divided by 6.4 is 0.781. Okay? All right. And the tangent we already figured out. What about C? C also looks a little tricky because it only gives us 2 of the 3 sides. And the sides it gives us are slightly different than the one we just did. Let's see. So this one, it looks like they give us the opposite and the hypotenuse. So for this one, the sine of alpha is very easy to figure out, right? Because the opposite is going to be 10, the hypotenuse is going to be 14, right? So if we wanted a decimal for that, we could say it's 0.714. Now to find the cosine, we don't know the yellow side, but remember we do have Pythagorean's theorem. And Pythagorean's theorem works not only if you don't know the hypotenuse, but any of the other sides too. So we could say, let's call this yellow side A for adjacent. So we could still write Pythagorean's theorem as a squared plus 10 squared equals 14 squared. And then we'll just use algebra to figure out what a squared is. So like, for example, 14 squared is 196. And 10 squared, of course, is 100. And a squared is just a squared because we don't know what it is. Okay? And then we're going to subtract 100 from both sides. And then we'll get that a squared is equal to 96. So a is equal to 96 square root is 9.8. Okay, so a is 9.8. So now we could write the cosine because we know that a is 9.8 and the hypotenuse is 14. And we can even find a decimal value for that. And these are, these decimal values are, even if they look exact like this, remember we rounded this, so they're not exact values. Usually they're irrational numbers. Usually they're square roots. Now we're going to find the tangent. We already know the yellow side is 9.8. So the opposite would be the red side, which is 10, divided by the yellow side, 9.8. And we get 10 divided by 9.8 is, it's pretty close to 1, isn't it? 1.02. Okay. And that's the funny thing you'll notice about tangent. Tangent can be practically any number, and sine and cosine are limited to -1 to 1. And in most of the problems that we do in this class, it's going to be limited to 0 to 1. Okay, so, but it's not unusual for tangent to be something bigger than 1. All right, moving on. Number 4, for each angle, write down a trigonometric equation to link the angle beta, another Greek letter, and the side marked x. Okay, so we want to link these two with a math relationship. And of course we're going to do that with sine, cosine, tangent. Now which sine, cosine, tangent equation are we going to use? Well, we see that x is the opposite, and we see that the other side given is 10, which is the hypotenuse. So we have the opposite, we have the hypotenuse. That would be sine, right? So the sine of beta would be equal to the opposite x divided by the hypotenuse 10. Okay, so there we have a trig equation which links the side x to angle b. Okay, now if we knew one or the other, if we knew beta, we could figure out x, and if we knew x, we could figure out beta. But since we don't know either one, all we have is a relationship like that. Okay, let's try to do the next one. So in this one, it looks like the adjacent is known because the side that is immediately next to beta, which is not the hypotenuse, is 12. And then we also seem to know the we don't know the opposite, but we have a name for the opposite, which is x. We're going to try to relate the opposite with the angle beta. So we have the opposite, we have the adjacent, so that is a key to use the tangent function. So the tangent of beta is equal to the opposite over the adjacent, and so now we're done. Okay, now for this last one here, we have the opposite is 14, and then the hypotenuse is x. So we're going to have, let's see, the sine of beta is equal to the opposite 14 over the hypotenuse, which is x. Okay? All right, let's move on. Find the lengths of the sides marked with letters. Give your answers correct to 2 decimal places. Okay, so they want to know, for example, here, what is the height? And here they want to know what is the m value, and here what is the t value. And this is kind of like the last problem we did, except for in this case, they're giving us the length and the angle. So using sine, cosine, or tangent, we'll be able to figure out exactly what h should be. So first of all, we're going to try to make a relationship between the three known things here. One of the things we know is the opposite, because it's opposite from that angle, right? The other thing we know is the adjacent, because this is the yellow one, right? So if we know opposite over adjacent, that means, or if we know opposite and adjacent, then we could make a ratio opposite over adjacent, which happens to be the tangent function, okay? So we can say that the tangent of 46 degrees is equal to the opposite, which is h, over the adjacent, which is 3 centimeters, okay? And then we can actually find the tangent of 46. So you have to do that on the calculator. It's the first time we're going to use the calculator to figure out a trig function. So we're going to tangent, we just press tangent, and then we do 46. If you've ever done this before on a non-TI-84, you'll notice that the order is different. Usually in another calculator, you'll put the angle first, and then you'll press tangent. In this calculator, you press tangent first, and then you press the angle. 1.04, okay? So 1.04 is equal to h divided by 3. Okay? Now how do we complete the algebra here and actually figure out what h is? Well, we're going to multiply both sides by 3, right? If we multiply both sides by 3, the 3's here cancel out. 3 times 1.04 is 3.12. So h is equal to 3.12. All right. Now, next one. Looks like we have the adjacent and we have the opposite again, right? So that would be tangent again. So we'll do tangent of 26 is equal to the opposite, which is m, divided by the adjacent, which is 10. And then we're going to find the tangent of 26 by pressing tangent 26, and we get 0.488. So it's 0.488 is equal to m divided by 10. How do we get rid of this 10 here and get m all by itself in algebra? We multiply both sides by 10. So that'll give us 4.88 is equal to just m. And so that's the answer there. Next one, number 5. We have, looks like we have the hypotenuse this time, which is t. And then we also have the opposite, which is 100. So now we could do sine, right? Because sine is the opposite over the hypotenuse. Sine of 15 degrees is equal to the opposite, 100, divided by the hypotenuse, t. And the sine of 15 degrees is 0.259. 0.259 is equal to 100 divided by t. Now we're going to multiply both sides by t to get t out of the denominator, right? Because it's very inconvenient to have t in the denominator. So you multiply this side by t, you multiply this side by t. The t's cancel out here. On this side you have 0.259t, and that's equal to 100. Okay? Now we need to get t by itself, so we're going to divide both sides by 0.259. Divided by 0.259. So we're going to have t is equal to 100 divided by 0.259, and that equals 386. Now, does that look reasonable? Yeah, it does, because this is 100. That looks like it could be 386. And remember, it's 386 meters, and in this case, it's 4.88 centimeters, and in this case, it's 3.12 centimeters. Okay, on the exam, you want to make sure and you put the units there. Sometimes they're going to be checking for that. Okay, and that is the end of page 2.